Hello and welcome to AVLI, AP Computer Science A. My name is John Maxwell, and this is a class summary of what went on last night, covering the topic arrays. Well, we had some introductory questions last night, and we asked what an array is, and we kind of covered a lot, but the answers were that people noted it was an index collection, a lot like a string, with indices beginning at 0 and going to 1 less the length. So if the length was 10, then the indices that you could put in were between 0 and 9 inclusive. It was also brought up that an array holds a single type of data. So when declaring an array like a string which holds just character information, an array contains perhaps an int, perhaps a string, but only one type. Towards the end, we discussed how to get around that rule, but that's not the topic of discussion here. And so we introduced the concept of a homogeneous, meaning all the same collection of values. And on line 8, we see this collection being length 3, and this is a declaration statement, and it's a collection of int values. So you couldn't put a double in there, you couldn't put a string, just ints go there. And because it's the size 3, the values can be stored at position 0, 1, and 2. And when you declare it, all the values are 0. So that would be the same if it was a double array. Primitive data types are all set to their default values. Now, you just are not limited to putting in primitive data types like int, double, char. You can also put in object types. So here on line 9 is an example of a string array, size 5, storage in positions 0 through 4 inclusive. And when you declare an array of that type, which are reference objects or not primitive data types, but objects, all the values are null, meaning they haven't been created yet. We'll just leave the explanation of what null is to a later discussion, but null is uninstantiated objects. We talked a little bit about instances and what is an object, to differentiate from primitive data types. And we remarked about instantiation cafe, which you've been glued to the screen with. Now, there's an alt way of declaring an array, and it's here, and it makes use of what is called an initializer list. And basically, I'm creating an int array called nums2, and inside the array is, or are, 6 values. So if I were to declare it, it might be equal new int square brace 5, but the values are stored at indices 0 through 5, and they're automatically placed 10 in the 0 position, 5 in the 1 position, so on and so forth, until index 5 gets the value 101. So it is such that you can declare arrays pretty easily. Some of the drawbacks are there is no way to resize them easily. It can be done, but obviously there's no way to resize an array right off. So the calculation of how many values it will hold is important. The other thing to know is as you go and work them in the real world, you may put 1 or 2 values one day and the rest of the values will be empty. So you want to keep track of how many values are in and how many spaces you have unfilled in an array as you work with them in the real world. Most of the AP Computer Science will present to you fully populated arrays, so that consideration is something real world, although we'll consider keeping track of how many values are in it. We also note that we can get the length of the array right here with nums.length. Note there's no parentheses like a string object to the length property. An array is not a class-based object. It is an object. It is a reference object like a string, but it's not a class-based object, and it has no methods. So it does have a property called length, which can be accessed. So keep in mind, while it is similar to a string in that it's an object type, not a primitive data type, it has no other methods like substring, index of, and things like that. Good luck, you'll have to create those on your own. So I do want to point out this is a commented thing. I guess I'll uncomment it so you can see it a little clearer. You can assign to a particular index, for example nums2, a value, and so I replace 10 up here with 12 for no reason other than this presentation, but I do want to show you how you assign values to an array. So I'll put that commented here, and I'm going to run this in a moment, but I want to show you that because they're an index collection like you learned in strings, they go hand in hand with a loop, and in this case a traditional for loop. So since all indices begin at 0, we put the loop counter variable I at 0, and we stay away from nums.length, and we go up by 1, and we store within each value num square brace 0, square brace 1, and square brace 2, because the size, recall, is 3, the 3 values that we want to run. And let me just do this. Okay, outputs the length of the array here in line 12. That's the value 3 that comes in here, and then invites me to enter values, so I will. I'll enter 55, 17, and negative 67. And that's it. But it is a perfect example of how to use a loop to traverse, keyword, move from beginning to end, traverse, okay, the array for the purpose in this case of entering in values. So we're going to move on. We've covered declaration and initializer list. We covered how to assign values, and we demonstrated the length property as well as the use of a for loop in conjunction with an array. So I'm going to move this comment a little further along and just leave this commented for later, okay, and say I can output them as well with the space in between using a traditional for loop. So I'll enter in the 3 numbers again, 55, 17, minus 67, and this is a discussion here, okay. I asked what's being outputted here with this line when I just asked output nums, and we got a variety of responses, okay. The values being outputted, 55, 17, and negative 67, are actually occurring with a for loop here. similar to the loop that we use to increase input the values. But what's this? What's this 723279CF? Okay. Well, it's kind of proof of concept that this is a reference variable or an object of the type array, and it's the memory address. Okay, so this is the value of nums. It's the storage address in the memory. Okay, and normally you don't have to worry about that, but like the takeaway here is you can't use a system out.println and put the variable name nums in to output what's in the array. You have to methodologically go through each value using a loop. Okay, example 22 through 24. Keep in mind that idea that it's a reference variable. So I'm just going to change this and begin something else, which is ending this. It's probably creating an error down here. Yes, it is. Okay, so I want to like leave this. Yeah, right here. Hopefully, no, it goes this way. Sorry about the commenting. Okay, I think it all runs. Let's examine a while loop, which really uses a counter K. And we asked at this point, what's an algorithm? And one of the things that you need to be able to accomplish with an array, particularly events, is to sum or to find the minimum value or the maximum value or to find the average of value and set of values. Those are common algorithms, and they're used every day in computing. You know, what's the sum of all the sales that I made today, for example? So we declare a variable called sum, and we go through while k is less than nums2 dot length. Recall that nums2 is up here with these values, okay, already populated. By the way, I calculated them out last night. You can total them up. It's 116. So each time we add the value at a particular index to sum and increase the counter by 1 so that we progress towards nums2 dot length. And then we output the sum, and I'll show you what goes on. Okay, we still have the three numbers to enter. 55, 17, minus 67. Okay. The sum is really 116. Here's the reference, proving that nums2 is indeed a reference. Slightly different than the previous reference, I hope, maybe not. And then I want to point out a good library that's not part of the AP curriculum. It's up here called import java.util.arrays, and it has a variety of utility methods that work with arrays to allow you to resize them, print them, because obviously we found that you couldn't print the values in the array unless you used a loop. Well, there's got to be a better way, and someone created a library for it, and it's here, arrays.toString num2. We'll talk about toString methods later on, but most classes have a toString method. Basically, it's a method that's intended purpose is to represent. We represent the object in a way that humans can understand. And here is the way the arrays.toString output works. Notice the square braces. It's a lot different than using a for loop to do that. Okay, but it's a nice way. And if you want to check the state of the array, arrays.toString, and I encourage you to like Google right now arrays API Java and take a look at the methods within the arrays class. It's a great library. Recall that you need to import it up here if you do use it. Okay, so that's pretty good. Okay, I'm going to just take this out and progress along. Okay, and show you something I bet you wished you knew. Okay, so I'm going to just change this to a slash like that, and I kind of, I think, screwed up that. So that is, no, yeah, that's right. I want to put this over here. And it's kind of annoying asking me to input those values. Okay, so I'm just going to leave them there. All right, take a look at this. We have a string, which is a date, very much like your assignment last week, and this is why we show you. The AP Quick reference sheet, which I referred to in the past, asking you to print it out and keep it handy, it will be available on the test, has one method that we didn't cover. We covered substring, index of, dot equals, compare to a little bit, okay, but we didn't really cover this method called split. And what it does, test.split at the slash, is create a string array, okay? And since there's 3 parts at the slash, the month goes into part square brace 0, the day goes into part square brace 1, and the year is put into part square brace 2. So let me run this and show you how it outputs. Enter 3 numbers, 55, 17, minus 67. And basically what we've done is rearrange the date from 05/19/1999 to 19/05/99 by recognizing that the string test is split each time it encounters a slash into 3 parts, and these parts are accessible by index. Okay, so it's a good way to look at a string, and works hand in hand with the array unit. And I didn't teach you the split method until now, so I think that's kind of important. Okay, so I'm just going to take this one out and convert that in, and then take this one out and talk about like one of the other things. Okay, so I really don't want that. I want this. Okay, so we're talking about another algorithm, which is finding the minimum value in nums, and I've repeatedly entered them in as 55, 17, negative 67. And so we know that negative 67 is the minimum value. Okay, 6, 7, right? We know that, kind of nonsensical, but like the computer doesn't know it. All right. So if you've ever played, King, or Ruler of the Raft, or King of the Hill, or Queen of the Hill, you realize that the first person up is the dominant ruler, okay, and then someone else comes off and pushes them off, and they become the ruler, okay. So for the sake of argument, we're going to say that Whatever's in the 0 position is the ruler. It's the minimum value. And what we do is go through the array with a traditional for loop, and with an if statement ask if that value is less than min. And then we make the minimum value that value which we encounter in the for loop, which is less than what we thought was the minimum previously. And at this point I asked, why don't you just set min to 0? And someone correctly answered, what if they're negative numbers? Or what if they're all positive numbers but all of them are above 0? Then 0 would remain the minimum value. So it's a good bet, a big mistake by rookies, to not set the minimum or the maximum to be the first index in the array. So that's important consideration to take away, and let's run this and just go with it. So enter the same numbers, 55, 17, negative 67, and here we go. The minimum value is negative 67, so it correctly identified it. But this is another algorithm, a solution to a problem. The previous one is how to sum up all the values. This one is about how to find the minimum value. Okay, it's a classic. Many of the algorithms that you'll use with an array include a loop and an if statement within it. So pay attention to that basic form. Okay, there have been FRQs in the past that say identify all of the values that are less than a certain number and put them in their own array, and so it's going through the array and identifying according to a criteria and doing what they ask. So loop, if statement within a loop is a classical. So I'm going to take this and control exit and put it right here and have a discussion about here, which is I'm going to take this and move them down, control X, and just move them down, change them. Let's talk about it for a second. Here is an array coming in as a parameter, okay? And it's called n. Take a look, n, all right? But up here, I'm sending in nums, all right? Nums is the actual parameter, n is the formal parameter, but it's an alias, okay? N is an alias of nums. So if I change one value of n, in this case the 0 position, would it change up here? Okay, and so really what I want to do is take this and put it down here. Okay, so let me run it. Enter three numbers, 55, 17, negative 67. Okay. Oh, yeah. Oh, a change in the method resulted in a change up in the main section. All right, because nums get sent in as what? A reference. So here, I'm going to give you the key to the locker, okay, which is the reference, the memory location. And you can do what you want in the locker. You can change a value, and that's the way a reference variable works. Now, you may have heard that a string is an immutable object. That's the one exception. Every other reference object that we'll encounter this year works this way, except for string. Okay. So here we have change them, sending nums down. Around here it's alias is n, but it's referring to the same location in memory. We make one change. Okay, all right. And it comes back and outputs that change here. So now we've had a discussion of using an array as a parameter. I do want to say, well, this is void, okay, and this is, I can return a new array that way. It just doesn't make sense because I don't have a return statement, but you can certainly return an array. So I'll just change that back to void. Okay. All right. Uh, Let me conclude by my most famous statement. The art of programming is the art of passing messages to and from different parts of the software system. Okay, so previously our understanding was that like in come the parameters, out comes the return type, and that is a way of communicating within the software system. But like another hidden way is the use of reference variables like arrays, which allow changes within methods and being able to have those changes reflected in a different part of the software system. So we do want to keep aware that, like, it's about communication. So, speaking of communication, reach out if you have any questions. Thank you.